So here's the light that I fixed in a previous video, and I did some cleaning up and I did up the schematic, which you'll be seeing shortly. I'm gonna turn it on to its 75% mode, and right off the bat, that one area over to where the two resistors are between the battery pack and the LEDs, boy is that getting toasty fast. It's up to 52 degrees C and climbing. Of course, I am also keeping an eye on that battery pack, make sure it doesn't warm up. Okay, we're up to probably going to be 60 degrees in a moment. 61. So this thing's actually getting pretty toasty. Now this isn't the proper distance to have this from that item. This is actually meant for much further away. But at some point in the near future I will be testing this to see how accurate it is against thermocouples. Okay, we're up to, if I can get my eyes focused, 67 degrees for the hot spot. And battery's still cool, that's good. Let's see if I can actually, where the circuit protection is, or the voltage protection is, looks like it's still staying cool. We're up to 76 degrees now. This is, and I'll move it over so you can see the spot I'm aiming at, which is where the red wires are. Oh, I've got the focus locked on this. Let's get this back in. Get it aimed over there. So it looks like it's topping out around 70 degrees when you've got the lights on 75% mode. This is definitely toasty. The rest of the board's fine, nice and cool. So I think those resistors are probably being stressed a bit. So at this point I've already done the schematic, but it's coming up next. So since I've got this open, I figure I might as well get a schematic out of it as far as I can go. I've removed the module here. This detects the motion. It went there obviously. I've got the mystery 6088A over here, and I'll be getting into the schematic in a moment. We have the mystery chip over here, which has no markings. We have the infrared sensor here for the remote control. So I'm just going to put this, I'll show you the other side. Not a lot on the other side. So let's look at the schematic. And I'll bring it down. Going basically from left to right from the circuit board, we had the three wires heading out to each of the LED panels, and the three black coming back, of course. We come over, and here's the switching. We have A2SHB, two of them, basically in parallel. They are N-channel MOSFETs. That one. And, okay, I had to put it the proper way. The source is over here. Gate is here. Gate's being driven by pin 5 of the chip. It's no longer questionable. I was able to get a good look at it. So basically this chip is going to be turning the lights on and off, or flickering, etc. There's a R5, which is 100K between the gate and the source. Then we come up an LED, which I don't believe is actually working. Then we get up to the 6088A. So on one side you have battery negative, solar panel negative, then one lead going off to R3, which is 1,000 ohms, and that hooks up to battery positive. So this chip most likely is looking after, solar panel positive comes through a diode and then heads on over. So this part is most likely looking after charging up the lithium-ion battery. Now, when it gets turned on down here, it's dumping the 4.1 to 3.7 roughly volts through these two resistors in parallel. Boy, this could be a hot spot, as I believe I probably already showed, because I think I'm going to do the thermal imaging at the beginning. So if anybody only watches it, great. But yeah, all of that going through these two little service mount resistors. But as we go over this way, and we've got some power here, this hooks up to here. We go on to the other side of the board. As I say, I don't know what this is. It's also going to be controlling, here's the sensor down here, the motion sensor, and determining when to turn it on, off, etc. So this is probably a microcontroller dedicated to this thing. Then we have our passive infrared detector here, which is simply taking the stuff from the controller, wherever that crawled off to be, up here. So when you're pushing the buttons here, it's getting the signal. It takes a signal and down to pin 7. The pin 1 on it over here is actually going to the power supply. This is a 7530L, most likely a low voltage dropout regulator with a cap on one side, a cap on the other, and this here, which is hitting roughly over to what I would call kind of quasi-ish ground relative to the solar panel. Of course, its output then goes down to the motion sensor. It goes over to this sensor, and let's see, it also goes up to pin 1 of this chip. So that's about it for the schematic. As I say, not much you can do when you don't know that. But now I'm going to reassemble it all and shoot the first part of the video, which will show the infrared image of the circuit board. So the first thing is to solder this back in. Oops. Hopefully that's working. Good, got one. Now, come on. Use these as legs. And 2. And 3. And finish off that first one. So there's the sensor back. This one here I actually cleaned up a bit, and I'll put a bit more solder over here. this over. Speed up the video if I need to. Freshen up that solder a bit. Boy, this thing was pretty gunky. Watch the other video for that. Oops. And shoot the thing off at a high speed. Good. Those two are done. I'm going to actually now screw it in. There, screws are in. The next thing is the battery. Yeah, that was a surprise to find out this thing was fully charged. It looks like it's got a part of a protection in there, but I'm not cutting into it. Okay, get that out of there. Go for the positive first because it's actually the hardest to put in. Okay. There's that one. Now, oops, battery negative. And it turns on, whoops, hold it for longer. There. And to prove it still works, here we go. Excellent. Now I just need to put this back on. And now I'm going to shoot the first part of the video.